Okay, let's look at first example of a Laplace transformation circuit analysis. So here we have a circuit of R and C, right? So first of all, we need to draw. We need to redraw basically. We need to redraw the circuit in frequency domain, in S domain. So this is the circuit in time domain. Okay, you can simply recognize it by the term or the symbol here T, right? And also the capacitor is in this unit, farad unit, all right? And I is also in T as well. So this is in time domain. So first step is to redraw the circuit in frequency domain. So the current is still the same, right? The current is still the same, or the current source is still the same. I is still I. However, the IT is now IS. And what is the IS? So you have to use a Laplace transformation table. So you have to do Laplace transformation of 3e or 3 exponential negative t, right? Transform this into S domain, which is 3 over S plus 1. This is simply simply obtained by referring to the table, Laplace transformation table. All right. So so now we have transformed the current source. Let's look at the resistor. R equals 10 kilo. Right. So in resistor, if you recall, the resistor is still the same in S domain. So resistor in time domain is similar to resistor in S domain. So that is as simple as that, right? Now we have to look at the capacitor. So capacitor in time domain C is 1 over SC in S domain, 1 over SC in S domain. So you can just simply do the calculation. 25 micro here, 25 micro, replace C with 25 micro, you will get 40,000 over S. All right, so that is the value of 1 over SC, the value of the capacitor in S domain. All right, now the question asks us to find the output voltage both in S and time domain. So this here is the output voltage, this here is the output voltage, this is in time domain, this is in S domain. So we have to obtain these two. So basically you can obtain the output voltage by using Ohm's law. V equals IR. Okay, V equals IR here, right? So V is the output that we want to obtain. I is the current source here, and R is the total impedance. All right, so you have to calculate the total impedance, which is R in parallel with capacitor, right? R in parallel with the capacitor, or 1 over SC. So this is the impedance. All right, so if you can perform, once you perform the calculation of the impedance, all right, then you will arrive to this answer. Okay, try to do the calculation, and then you will get this, and then finally you will get this. Alright, just replace R with 10k, replace I over SC with 40,000 over S. Alright, and then replace IS with 3 over S plus 1. Right, then you will get, finally you will get this. This is V out over, this is V out S, or V out in S domain. Now, you can leave the answer in this form. This is correct. This is the V out in S domain. However, if you want to calculate the V out in time domain, you have to do inverse Laplace transformation of this term. Okay, you have to do inverse Laplace transformation. So in order to do inverse Laplace on this, you have to do partial fraction decomposition, in which you will separate these two, right? So now, once you have arrived to this term, you can simply refer to the Laplace table, and in the Laplace table, this is basically 40 e minus 40 e minus t, and this is 40 e minus 40, right? So which is this? So this is the answer, the output voltage in time domain. Alright,